In this example, I'm given a circle, I know the radius, and I know the central angle is 56 degrees. And in the first part, I need to find the length of the arc determined by theta. So what this means is here I am on my circle, here's my central angle, theta. I need to find the length of the arc S, determined by this central angle. So we need to use the formula S equals R times theta, but it's very important to remember that theta must be in radians. The most common mistake students make is they will use the 56 degrees in this equation and then wonder why they have the wrong answer. So here's the formula. All I have to do now is figure out what 56 degrees is in radians. Remember, the way you convert any angle from degrees to radians or back again is you must know the conversion factor. The conversion factor is 180 degrees equals pi radians. So to convert between degrees and radians, I start with what I'm given in this case, which is 56 degrees. And then I'm going to use my conversion factor, and I'm either going to multiply by 180 divided by pi, or pi divided by 180. Well, it's very simple to figure out which number goes in the denominator. You look at who's in the numerator. Up here, it's degrees. So you have to put 180 degrees in the denominator, so they will reduce with my degrees on my 56 in the numerator. So that means I have pi radians in the numerator. Double check, did my degrees cancel out? Yes. The only thing I'm left with is radians, which I'm looking for. So now the only thing I have to do is reduce anything. And does anything between 56 and 180, do they have any common factors? Yes, I think 4 divides into them both. 4 goes into 180 45 times. 4 goes into 56 14 times. So my angle in radians is 14 times pi over 45 radians. So this is my angle that I need to use in this formula up here. So now I've found theta in radians. Now all I have to do is use my formula, S equals R theta. Well, R, if you remember, is up here. R was 9 centimeters, so it's 9 over 1. Times my angle theta, but remember we must use it in radians, 14 pi over 45. Now, does anything reduce? I think 9 goes into here once, 9 goes into 45 5 times. So finally, what is my arc length associated with 56 degrees on a circle of radius 9 centimeters? If I want the exact answer, it's 14 pi over 5, because as you can see, I have 1 times 14 pi in the numerator, which is 14 pi over 1 times 5 in the denominator. And remember, arc length is a linear distance, so it's going to be in centimeters. And then depending on the problem, you might have to approximate it to, I don't know, say 3 decimal places. That's what I'm going to do for this one. So in my calculator, what I'm going to enter is 14 times pi divided by 5. And make sure you use the accurate pi that's on your calculator. When I did that, I got 8.79645 ... Since I want to round it to 3 decimal places, that approximates to this 4 here is not going to round the 6 up. It's going to stay the same. So it's 8.796 centimeters. Now, in part B, we have the same circle, radius 9, and with the same central angle, but this time we need to find the area of the sector determined by this angle. Well, remember, the area of a sector is like a piece of a pie. It's this area in here. And just like in the previous problem, we need to know a formula. The formula A is 1/2 r squared theta. But again, theta has to be in radians. And remember, in the previous part, we already converted our measure of 56 degrees to radians. So I think we're ready to go with the formula. So area is 1/2 the radius squared. Remember, our radius in this case was 9. 9 squared over 1 times theta. We must use it in radians, so I want my 14 pi over 45 radians. Now it's basically just simplify the arithmetic. 1/2, 9 squared is 81 times 14 pi over 45. So the last thing we have to look at, is there any number in the numerator which will reduce with any number in the denominator? 2 goes into here once, 2 goes into 14 7 times, and I think 9 goes into 81 9 times, 9 goes into 45 5 times. So now what is my answer? Well, if I look in my numerator, I have 1 times 9 times 7. 9 times 7 is 63 times, don't forget that pi over here, all divided by 1 times 1 times 5, which is 5. And don't forget, this is area, so it's going to be in units squared, and my units are square centimeters. So this is if they ask you for the exact answer, there is my exact answer. And again, you might have to do the approximate number in the calculator. So you will do 63 times the exact version of pi divided by 5. And when I did that on my calculator, I got 39.5840 ... Since I'm rounding to 3 decimal places, that's the 4. The 0 after it will not change the 4. So my answer is 39.584 centimeters squared.